Hi, William.
Hi there, how's it going?
Oh, I'm fine, thanks. How are you?
Not too bad. I see you've got some blocks there.
Yeah, I've been building a tower. I mean, to build a tower like that is a little bit dull. So what I've been trying to do is build something a bit more artistic or a little bit more with a little more ingenuity and trying to get. Do you see how if I push that just very slightly further and go past the point and it tips? So if I can get it just to the point before it tips and then move the next block along until that just balances and try and make an arch in this way.
Oh, I thought a tipping point was a metaphor. This is a literal one.
It is, and of course I'm not allowing any counterweights or counterbalancing or bridging with other blocks on the right hand side to stop the tipping being allowed to taking place rather. So what I'm just trying to do is get, you see how that block, the top block now has come beyond the edge of the base of where it started. So I've moved that out now. It's completely suspended. Well, it is it is for the moment. That may all change any minute if I go past a little too far, which is looking very much like I'm testing it to the point of destruction now. I dare let go, but only just. So I was wondering, I haven't put a tall enough tower here yet, and I'm being a little bit untidy at the bottom, but I was just wondering, would it be possible, you can see now how far over the
Good grief.
The top one is. I wondered if I could get it so far out that maybe it was even 1.5, 2 blocks out, and whether or not that was possible.
And you haven't cheated with glue or anything like that?
I haven't put any glue on, I haven't used any blue tack, and also, as I said, I haven't put any counterbalancing on the right side to stop it tipping. It's all a single block moving out. I mean, if I were to put that one on now, that would certainly bring the thing down.
Wow. And the blocks are the same mass all the way along. You're not very heavy at one end.
No, they're all uniform blocks. They're actually dominoes with very pretty pictures on, but they're all just rigid wooden blocks, which is what gives me an advantage for building out. They are rigid, that helps.
Okay, well, I've got a whiteboard, so let's see if we can work out what all these optimal distances are.
Okay.
See if we can do some screen sharing.
And while you do that, I'll very carefully move my construction out of the way.
Okay, so hopefully you can see the whiteboard. I see we've got a picture here of one you did earlier, although not quite as impressive. You know, this first block's only just over the edge. So,
prototype.
I see we've had a lot of practice now. So let's see. So, well, I guess the question is, suppose I'm just going to draw a lump of n-1 blocks. And what we need to do is kind of do a lever balance. So these blocks are going to sit over the nth block. And then the question is, where can we fit the block after that? So we need to work out where the centers of the mass are. Now, for the n+1 blocks, if you're done it directly, then center of mass should be just sitting on the edge of the nth block. Now, just the nth block on its own, center of mass should be in the middle. And then the whole assembly. So let me do that in a different color. So the nth block and the n+1 blocks, they should be sitting directly over this one.
Mm-hmm.
So let's see, just to make the numbers nice, I'm going to say that each block has a width of 2.
Oh, yeah.
So let's see, so from here to here, I'm going to say is 1, and from here to here, I'm going to say is 1. So for example, your top block just here, that's out by a distance of 2. I'll just draw that on. So this distance here, I'm going to call x. And then since this and this, these two arrows are a distance 1 apart, this is going to be 1 minus x. And then all I have to do is balance moments or do the lever equation, however you want to think about it. So we're going to say that the total mass, so that's n minus 1 times the mass of a single block, which I'll call m, times x, must be equal to just 1, or m, mass of a single block, times 1 minus x. And then this is the equation I can solve to work out what x should be. So first off, I'm going to cancel the m's, and then bring all the x's over to one side. So that's going to be n minus 1 x, and then this x I'm going to take over to the other side, so that's plus x equals 1. I can cancel this and this, and then I've got x is going to be 1 over n. So so this is going to be 1 for my first block, or 1 over 1, half for my second block, third for my next block, and I'm not going to have room to get a quarter in. Yeah, so you've got a sequence there, and then if you want to find out how many blocks you are across, you have to add up terms of your sequence and then divide through by 2, because we're saying that each block is 2 across.
So we've got, this is a sequence we can recognize as being an infinite sequence. That'll go on as n does, as n goes to infinity, we can keep writing out those terms. And as you say, if we want to find out how far we're sticking out, we need to, from the initial pile, the initial starting point, then we need to add up these distances. So we get an example of a lovely infinite series when we add them together. And I say that's an infinite series, but can we show it's an infinite series?
Do you mean, is it got an infinite number of terms, or does it add up to an
It's got an infinite number of terms, and the sum, although we might call it infinity, I know you may argue about my use of the infinity. The series never converges to a known value. It just goes on and on and on. And one nice way of showing this is to have a look at the terms collectively, to group the terms together and to think about them relative to something that we can understand a lot more easily. So if we put the terms together in groups, leave the first term on its own, the 1, I'll come back to that in a moment. If we look at the second 2 terms, we can put those together and say, well, both of those terms, we've got 2 terms, both are greater than a quarter, so we've got 2 terms greater than a quarter, which together will be greater than a half. If I then take a batch, the next 4, I've got 4 terms And each of those 4 terms is, well, the last one is 7th. Each one's greater than an 8th. And so together we've got 4 terms, all greater than an 8th, which again gives me collectively 4 terms which are greater than a half. And actually, I can't write all these out, but if I look at the next 8 terms, and I can see that each of these 8 terms, if I went on and on, the last one, they would all be greater than a 16th. And so collectively again, those 8 terms, are greater than a half. I can then look at the next 16, the next 32, and so on and so forth. But essentially, coming back to the one, that's definitely greater than a half. So essentially, what I've got is a sum, which is half, plus a half, plus a half, plus a half. And our sum, this special series, which is known by a very special name, the harmonic series, is going to go on and on and on forever. So it won't just have an infinite number of terms, it'll have an infinite, it sums to infinity, if we're allowed to say that.
Well, you're the one who teaches an analysis course. So you're saying so this is a bound from below by what we'll talk about being is infinity in this context. Or we can make it arbitrarily large by including arbitrary numbers of terms.
Mm-hmm.
So the practical result is if you had an infinite number of bricks, or I probably don't want to say practical and infinite number of bricks. So the theoretical result is if you had an infinite number of bricks, you could go out an infinite distance. Now, I mean, an infinite number of bricks, that's hard to do practically. But I mean, how far out could you go with, say, a deck of cards? So if we don't include jokers, we're talking about 52 different cards. So in terms of how far out we'd be going, what we want to know is, so our distance, that'd be, so I'm going to put in a half. So then we've got a distance in terms of cards. Sum from n equals 1 to n of 1 over n.
Excellent.
And I did make a little table, although I see I didn't actually go up as far as 52. Let's see, so I've got n, and I've got d, the distance. So if n is 4, then we're going out about 1.04. So I think you already showed this. If you've only got 4 blocks, you can already go out 1 block's length.
And in analysis terms, we're talking about partial sums of the series, aren't we?
Oh, of course. Excellent. If I've got 10 blocks, well, that doesn't actually get me much further out. And I guess you can see that from your sum, that you're basically saying I need, say, 2 to the n blocks to get out another block's width. So if it takes us 4 to get out by 1, it's probably going to take us 16 to get out by 2.
Yeah.
32, 64 to get out by 4. So 10 only gets you out 1.4. And in fact, it's not until we get to 31 blocks you've gone out 2 blocks width, 2.01, so just below 32, which I think is what your sums in terms of halves would say.
Well, the sums to the half just give us that slightly easier way of adding it up, doesn't it?
And then I kind of stop at, oh no, I did work it out. So if we have the entire deck of cards, not counting jokers, which will actually help this much, then 52 cards should get out 2.26. So 2 1/4 blocks. So even with a pack of cards which has got 52 in there, you're still not doing much better than you did with just your handful of blocks.
And I think we ought to say as well that using a deck of cards, I don't know if you're going to take up the challenge, are you? Are you going to try and do the deck of cards challenge?
Well, why not? Let me stop screen sharing.
I think what we need to think about are the differences perhaps in the blocks that I was using.
Well, I've got a pack of cards, but I don't actually have anything stable to put it on. So I'm going to try and rest it on my hand. I'm sure this will be fine. Okay, so first card. Okay, so that should go out by a half. And then the next one, well, it should be a half if the card was width 2, but it should be a quarter of that distance.
No doubling.
And then, well, would that help me much? I think that would only halve the number of cards I had.
I'm not sure, because I think that building with the blocks are nice and rigid, will make a difference, will it, to building with the cards maybe?
Oh, I see. I think it might be the rigidity of my fingers rather than the rigidity of the cards that's going to be a problem first. Okay, so next card, on we go.
Oh, this is looking good. Oh!
I can do better than that. Let's try again.
Have another go.
Okay, my hand started shaking now. Okay, I can do this. Do this.
Normally we would say don't try this at home, but we would say today do try this at home, but put it on a more rigid surface. Don't do it in midair.
There we go. Okay, and I'm going to stop there. I think I've got the first card just beyond.
Oh, that was excellent. Very good.
I'm going to try to get off camera. Well, thanks for an interesting mathematical diversion.
And thank you for your extra input for the centres of gravity and helping explain the process.
Yeah, I'm sure I can do better with the cards. I might post a picture later.
Brilliant. I look forward to it.